All right, so we're gonna sketch together. It might be a good idea to have the handout that I sent out to you guys, or I post that online. Okay, and so you don't have to like draw everything. All right, I'll do the first one. Okay, and I'll have you do the rest. Let's say this one we have an ethyl acetate. We have to get the proton signals. All right. So first off, we have learned two main information on the proton NMR so far. We have number of signal and we have chemical shift. All right. So first off, how many types of protons are in here? One, two, and three. So three. You should say three signals. The rest is gonna be put this into the location, the right location. Okay. If you remember regular hydrocarbon, it's about 0.9, 1.2, 1.7. So number one right here look like just regular hydrocarbon, doesn't attach to any electronegative atom. So I'm gonna this is CS3, supposed to be 0.9, but it's better from the oxygen to carbon away from the oxygen. So I'm gonna go maybe a little bit higher than one, about one. Give it or take it. I mean, it's just approximate. All right, so it should be something right here. Now, hydrogen number two is right next to the oxygen. If you remember 3.7, I'm going to put 3.7 right here. All right. The real spectrum show this peak at about 4, but I mean close enough, 3.7 ppm. Number three, CS3 right here is not a regular proton. This is an alpha proton of a carbonyl. Alpha proton of the carbonyl 2.1. Right. So I mean, of any functional group, carbonyl, alkene, 2.1, benzene, so benzoic proton 2.5, right? So I'm going to put 2.1 right here, number three. That's it. Okay. All right. I want you to do on your own and then check with me. Okay. So next one, this one. All right. Let's forget. How many protons are there? I mean, how many types of protons? So we got, so be careful the symmetry there. So we have 1, 2, 3, 4, and on aldehyde, 5. You should see 5 protons. Start with proton number 1. So right next to the oxygen, 3.7. If you remember, put right there. Okay. Now 2 and 3 are on aromatic are on benzene. If you remember, 7 to 8. I'll put it somewhere right here. Yeah, 7 to 8, and doesn't really matter which one more shielded, more de-shielded. But I mean, it's a both signal around here. Okay. What we get? We get number 4. So number 4 is an alpha proton, right? Of the benzene ring and also of the carbonyl. The carbonyl itself, you give you 2.1. The benzene itself 2.5. Together, we have more power there. I will put about 3. They add up. This the de-shielding effect, they actually add up. There's a formula that you can calculate, but let the graduate student learn about that. For you, just like approximate that's enough. Okay. And the last one, number 5, aldehyde, really distinct, 9 to 10. I'm gonna put right there, about 9.5. Yeah, about 9 is fine. All right. All right, next one. This one, methyl acetate. So there are 2 types of carbon. All right, start with carbon number 1. So carbon number 1 is 1 position of the carbonyl. So you have to recognize that that's an alpha proton. About 2.1. Put 2.1 right there. The carbon number 2 right next to the oxygen. All right, oxygen. So that's 3.7. Put 3.7 right there. Yeah, what's difficult? All right, one more. We have this one, carboxylic acid, so acetic acid. So we have 2 types of proton, number 1 and number 2. Okay, start with number 1. Again, this is alpha proton. You have to recognize it by now. So 1 position of the carbonyl, 2.1. Put 2.1 right there. And the hydrogen of carboxylic acid is 11 to 12, really distinct. Aldehyde and carboxylic acid are distinct on NMR. I mean proton NMR. You know it right away. 9 to 10 for aldehyde, 11 to 12 for carboxylic acid. You have to use that. Even better than IR. Yeah, sometimes IR is not that accurate. All right. All right, this one, be careful. This one we got cis and trans, right? The alkene. Be careful, cis and trans. So we have how many protons? 1, 2, 3, and no proton in here. So 4. The terminal alkyne. Okay, so 4 proton. All right, start with proton number 1. So number 1 is 1 position of the functional group alkene. So this is an alpha proton. Alkene 2.1. Put 2.1 right there. 2, the same thing, also 2.1. Put next to each other, really close. Yeah, maybe 2 a little bit more de-shielded, but yeah, they're close enough. I put them together there. What else? We have proton number 3 is on sp2 carbon of alkene 5 to 6. If you remember, 5 to 6. On benzene, it's 7 to 8. Put 3 right here. Number 3. Number 4, that's an alkyne, a terminal proton of terminal alkyne, so 2.5 right there. All right, that should help. All right, the rest is gonna be practice, practice, and practice. So use them often. Now, please use it often. Maybe at the beginning, it takes some time. You have to look at to the chart and come back and to try to draw, try to indicate, like the practice it. But it's gonna get faster over time. Like alpha proton, 2.1 ppm. We have seen it 3 or 4 times already. Just repetition. Okay. All right, let's move on to the next